All right, welcome to 8.2. We are going to draw angles using radians in the coordinate plane. So last time we did degrees, so angles with degrees. We're going to talk about radians today. Okay, this is new to you. This is a trigonometry / precalculus thing. Radians is a different term of measuring other than degrees. If you've noticed on a scientific calculator, there's like a DEG button or a RAD button for switching between degrees and radians. That's what it's talking about. Radians is a different way to show your answer than the actual degrees. So we're going to draw angles using radians. We're going to measure angles using radians. We're going to determine coterminal angles using radians. So all the same stuff we did with degrees, but now we're doing it with radians. And then we're going to convert degrees to radians and vice versa. We're going to convert radians to degrees. Okay, so lots of stuff here that have to do with the radians. Okay, so before we do any of that, let's just talk about why radians are the way they are or why they work. And we need circles to kind of show that. So just a review for you guys, circumference. To find circumference, we always did pi times diameter. In other words, 2 times pi times the radius. So both of those are different ways that you can find the circumference of a circle. Okay, now we have these things called central angles over here. So this right here is called a central angle. Okay, this is a review from geometry. So it's the angle whose vertex is at the center of the circle. Okay, so both of the rays that form that angle are both radii. Okay, so this is the radius, and theta will represent our central angle, and this is our arc. Okay, so this shaded blue part right here, that's the arc. Okay, and it's represented by the angle that it forms. And then also arc length. You're not gonna have to find out what arc length is, but we're gonna refer to arc length as S. Okay, so arc length is gonna be known as S. And the way we find S using all that stuff, so let's say that our theta was 60 degrees, our radius was 8 centimeters. This is all given information. And we're asked to find out what the arc length is. So in order to do that, we're gonna have to do theta divided by 360. Okay, this is the formula, and this is from geometry. So if you took my geometry class, we did talk about this, times circumference. Okay, so theta divided by 360 times pi times the diameter. Now, we are not gonna actually times the pi, we're gonna leave it in terms of pi. Radians will always involve the pi symbol, okay? They'll always be in terms of pi. So for this particular problem, we're gonna take the 60-degree theta, we are gonna divide it by 360, and we're gonna multiply it by pi, and we're gonna multiply by the diameter, okay? The radius is 8, so that means the diameter is twice that, so our diameter is actually 18. And we're just gonna multiply all these things together. Now I'm gonna reduce that 60 over 360. We're gonna do a lot of reducing, simplifying fractions today. So here's a good first starter. 60 over 360 is 1/6. I'm just gonna move the 18 in front of the pi just because the pi symbol is just gonna stay pi. And we're gonna do 1/6 of 18. 1/6 of 18, oh shoot, it's actually 16, not 18. I just realized that. Let's fix it. You guys are probably screaming at me for the last like couple minutes. It's not 18, it's 16. Can you hear me? I heard you. It is actually 16. All right, so 1/6 of 16, we're gonna leave it in terms of a fraction. That gives us 16 over 6 times pi, so 16 over 6 pi. And we can reduce that even further. Divide both those by 2. We get 8 pi, the pi goes on top, divided by 3. So 8 pi over 3 is the length of that arc, okay? And that's in radians term. Okay, so 8 pi over 3 is actually the arc length. And we could find out what the actual number is by plugging in pi, but we're leaving it in terms of pi. So this is the arc length, okay? Now, if you notice 60 degrees is 8 pi over 3, let's try and do a bunch of, or the arc length is 8 pi over 3. Let's look at all the different ways that we can figure out what the pi button does, okay? So it's just different kind of things we can talk about here. So if I wanted to find, let's go talk about radians now. Sorry, I forgot to shift slides here. Okay, so let's talk about radians. Okay, so in radians, we have a couple of things. Radians are theta equals S, so the arc length divided by R, okay? So the radius. So the arc length divided by the radius will give us theta, okay? We kind of proved that backwards on the last slide. Now we can also find radians, radians. All right, so the radians, just putting it into words, same thing. So arc length divided by the radius, okay? So it's the same thing I just wrote there on the left, but it's in words, okay? And theta is going to be in radians, not in degrees, okay? Not in degrees. So let's go back to that. So here's the symbol. Here's theta. Here's the radius, and here's the arc length, okay? Let's use all the stuff from the last example. So we knew that this is 60 degrees. We knew that this was 8 centimeters. And we knew the arc length was 8 pi over 3, okay? If I wanted to know what theta was in radians, here's what I'm gonna do. I'm gonna do the arc length divided by the radius. So in order to do arc length divided by radius, we have to do 8 pi over 3 divided by the radius 8, okay? So dividing involving fractions means the exact same thing as multiplying the reciprocal. So that means 8 pi over 3 times 1 over 8. All right, and when we simplify that, we get the 8s can cancel out, and we get pi times 1 is pi over 3. So that is the radian form of 60 degrees. So this is pi over 3. 60 degrees is pi over 3. Okay, that's an actual conversion from from degrees to radians. Now let's take a look at how all these things are kind of relate to each other. 60 degrees, let's just complete this line here. Let's complete an actual semicircle. So that's a diameter. And remember, a diameter is 180 degrees, okay, in a circle. So half a circle is 180 degrees. So that means that we have 3 separate 60-degree sections that form 180 degrees. So that means each of these sections is pi over 3 and pi over 3, because 60 degrees is pi over 3. So when you combine all those pi over 3s together, what do you get? Okay, so I got pi over 3 plus pi over 3 plus pi over 3. That's 3 separate pi over 3s, which simplifies to just pi. So 180 degrees is the same thing as 3 pi over 3s. In other words, it's just pi, okay? This is something really important that we are going to use to determine any kind of radian, okay? Knowing that half a circle, that 180 degrees, is just equivalent to pi, we're going to use that for all the other things that we're going to do in terms of radians, okay? So half 180, half of a circle is pi. All right, so let's use that to do some examples here. First thing we're gonna do, so before I even look at this, anytime that we have a graph or a coordinate plane like this, here's what I want you to do. I want you to list, kind of like last time we listed 0 degrees, 90 degrees, 180 degrees, and 270 degrees. We did this for 8.1. We're gonna do the exact same thing, but we're gonna do it for radians this time, okay? So watch what happens. I still have 0 here, and that's a radian, okay? That's a radian, so I'm not gonna put degrees. And we know that 180 is equivalent to pi, okay? So let's kind of cut these in half. If 90 degrees is half of 180, then what's half a pi? Well, half a pi is an expression. It's 1/2 times pi, which is pi over 2. So pi over 2 is the equivalent to 90 degrees as a radian, okay? So this much, 90 degrees, is pi over 2. We go another pi over 2 plus pi over 2 is pi, okay? Now, what happens when we go another half pi over 2? That means we are going to get 1.5. So 1.5 in a nice clean fraction is equivalent to 3 pi over 2. All right, and if you go full circle, so pi over 2, pi, 3 pi over 2, we get 2 pi. So a full 360 degrees is equivalent to 2 pi. Okay, so for all of your coordinate planes with radians, that's how I want you to label them. I want you to have the 2 pi, the pi over 2, the pi, and the 3 pi over 2, just like this. And here's how we're gonna draw angles, or figure out, sorry, which quadrants they're in. So 2/3 pi. So where does that fall in terms of angles? Well, 2/3, I gotta look at it in terms of half and 1. Is it bigger than 1? Is it smaller than the other? So we do know that 2/3 is bigger than half. We know that it's bigger than half of pi. So it's gonna be past the y-axis. And we also know that it's less than 1 pi. So it's between half pi and pi, okay? So it's somewhere in between there. So 2/3 the distance of pi. So if we ignored this part of the axis, if we just completely ignored that and we cut this into thirds, we'd have 1/3, 2/3, and 3/3. So this is pi over 3. This is 2 pi over 3. And we'd have 3 pi over 3, which is just pi. Okay, so all of those things considered, that means the second line we drew is the 2 pi over 3. So it's bigger than 1/2, but it's less than 1, so it's about here. Okay, it's somewhere, or sorry, it's maybe a little bit less than half. So maybe something like this. Okay, this would be where the line would draw, so that would be quadrant 2. Question is, where's the quadrant? So all we have to worry about is the quadrant. Okay, you will be graphing the lines, but I'm just letting you know all you have to worry about is the quadrant right now. All right, let's take a look at my eraser here. Let's take a look at number 2. Okay, number 2, we've got 7 pi over 5. Okay, I'm gonna rewrite this because we need to know how many ones it is. So 7 divided by 5 as a mixed number is 1 and 2/5. So 1 and 2 pi over 5. So we have more than 1. This is greater than 1 pi. Is it greater than 1.5 pi? Okay, because remember, this is the same thing as 1 and 1/2 pi. Okay, same thing. So is it greater than that? No, it's not. It's actually less than 3 pi over 2. So it's between the pi and the 3 pi over 2. So it's somewhere in this quadrant here. So that would be quadrant 3 as an answer. Okay, we're not going to worry about graphing it yet. I just want to know the quadrants right now. All right, and the last thing, or sorry, number 3, sorry, switch colors. Number 3, we have negative pi over 4. So remember, when we talk about negatives, it's going clockwise now. So it's opposite, just like when we did angles. So when we go negative, this is actually 0. This is negative half pi. This is negative pi. And this is negative pi over 3 pi over 2. Sorry, make that a negative, clear negative. Okay, so we're going in the negative direction. So if I go negative 1/4, just kind of ignore the negatives and just go backwards. 1/4 is less than negative 1/2. So it's less than negative pi over 2. So but it's bigger than 0. So sorry, this would be negative 2 pi over here, going clockwise. So negative pi over 2 falls in this quadrant over here somewhere. So that means this is going to fall in quadrant 4. All right. Number 4 is positive, so I'm going to get rid of all these negatives here. All right, and number 4, I'm going to make this into a mixed number. So this is the same thing as 2 7s fit into there. So 2, and then we have remainder 5 over 7. So 2 and 5/7 pi. Okay, so that means if it went 2 pi's, it went a full revolution. Okay, so that's 2 pi right there. Full revolution is 2 pi. So all we're kind of looking at is just the 5/7, the 5 pi 7ths. Okay, so 5/7, that is greater than half pi, but it is less than 1 pi. So it falls somewhere in this quadrant over here. Okay, so if I went 5/7 pi, I'd end up here. So this is the additional 5/7. All right, so we would end up in quadrant 2.